Welcome you all to the week 1 activity of International FDP on Environment and Sustainability. Myself, M. Thangavel from the Department of Information Technology, Tyagaraja College of Engineering, Madurai, Tamil Nadu. The week 1 activity is the creation of video for subject specific environmental awareness. The subject that I have selected for this video is cloud computing, and the topic that has been selected for the environmental awareness is green cloud computing. The content that have been presented in this video has been majorly referred from the conference paper titled as an analysis report on green cloud computing, current trends and future research challenges. The web links has been provided here for the viewer's reference. In today's world, we use many digital devices like smartphones, tablets, smartwatches, healthcare devices, and sensors. All these devices have been connected to the cloud for the major purpose called data storage. And we use many applications in all these gadgets. So the major applications are like email, messenger, your WhatsApp, Facebook, like social web networks, your Flipkart, Amazon, e-cart apps, audio and video streaming apps like YouTube, broadcasting and enterprise entertainment services. All these applications are being accessed through the gadgets. These services are utilizing the cloud for majorly to store, process, share, and secure the data. So we use all these applications with some data. So all this data will be maintained on the cloud computing. So in today's world, we are depending more on the cloud technology. So this is the basic service layer architecture of the cloud computing. We have three different service layers: software as a service, platform as a service, infrastructure as a service. So in the software as a service, where we'll be having a front end part, we don't bother about the deployment of that application, the storage of the data. Rather, we need to have a browser to access all these applications like Google Docs, Salesforce, Office 360 and Gmail. And in case of platform as a service, we'll be having a platform where we can execute our applications like Google App Engine, Heroku, AWS, Benstack, or the platform as a service where you can create your own application and deploy it. And we have an infrastructure as a service where the hardware and the virtualization support will be provided with the background support of CPU, memory, network, and storage disk. So we have service providers like Microsoft Azure, Google, Compute Engine, Amazon EC2, where the infrastructure will be provided. You need to create your own platform, and above that, we need to create our own applications. So this is a basic service level architecture we have in cloud computing. The most popular search engine like Google has hosted all its services like Gmail, Google Earth, Google Drive, Google Play, YouTube using the personal cloud platform of GCF to offer high quality services to the worldwide customers. So cloud computing is addressing the majority of the problems encountered by today's business organization, but still they suffer from notable limitations. The limitations are huge power consumption, more CPU idle times, need of deploying the resources at upper bound, emission of carbon gases, and producing huge electronic waste material. So, how we are going to address these problems? That is a major notable limitation which is available in cloud computing. So we have a global statistics on total cloud energy consumption. See, in energy consumption, electricity consumption in 2007, we have units for data center and telecom, which is totally 623 billion kWh, that is kilowatts. But in 2020, it is going to be 1963.74 billion kilowatts, and relevant to the carbon emission is going to be 1034 mt CO2e, that is carbon emissions, CO2 emission. So think how it is getting increased drastically. So we need to address the limitation of the cloud computing. How we are going to address this limitation? So there comes the beautiful concept called green cloud computing. So even though your cloud computing became an impressive solution to address the challenges of storage and process of high volume data with low cost, high speed, on-demand and pay-per-use characteristics. All these characteristics will be attracting the customers like us. But rapid progression has been recorded in the area of cloud computing and its services. Attaining the implementation of green cloud is still under development due to the lack of research and several barriers in its implementation. So why it is lack? Why it is still in research? So we need to know what is actually the green cloud computing is, so that we can develop our own application which can be an infrastructure related to green cloud computing. So green clouds are committed to design an eco-friendly, energy-efficient, maximum resource utilizable, low carbon emissions, and long-lasting recyclable. So this will become a characteristic or a advantage if we implement green cloud computing infrastructure in all the business purposes as well as for the individual user purposes. In order to satisfy ever-growing enterprise data storage and processing need, the cloud service providers are coming out with cutting-edge technologies like green cloud computing in cloud architecture design to reduce the huge power consumption, water consumption, need of physical hardware peripherals, infrastructure, and harmful carbon emissions. So to protect the environment from cloud negative impacts, the service providers must adopt and update their cloud infrastructure towards green computing. So now we can realize what is the need of the green cloud computing. So researchers focus on designing efficient cloud with various characteristics like power management, virtualization, high performance computing, load balancing, green data center, reusability and recyclability. So here comes the architecture of green cloud computing. See how beautiful it is. We have a cloud user and we have various cloud setup. So cloud A, cloud B and cloud C. So we need to have a service provider called green cloud provider. So we need to have some set of policies which must be relevant to the green cloud characteristics and carbon emission directories. So here comes some of the major things which need to be monitored and managed by the cloud service provider, that is green cloud service provider. First one is power management analysis. So how much power consumption is happening for each and every process or for each and every user for each and every day, like that some management analysis need to be done. And scalable process scheduler. So with the available infrastructure, how it can be maximum utilization can be performed without leaving the original characteristics of cloud computing. Next, multi-tenancy implementation. That is, a single hardware can be shared among multiple users for process execution. So how it can be implemented effectively. And resource calculator. So how many resources are available, how many are in utilization, whether it is maximum utilized, whether it is underutilized or minimum utilized, that need to be calculated. Next, reutilization monitor, how well the resources can be reutilized, and load balancing, which is the most important thing. So these kind of management and monitoring activities need to be taken care by the green cloud provider. If it's so, the environmental can be taken care in a safer manner. So the major characteristics of green cloud computing are energy efficiency, virtualization, multi-tenancy, consolidation, and eco-friendly. So how come it become the characteristics of green cloud computing? First, energy efficiency. That is, deploying the efficient power management techniques to reduce the power consumption at each cloud object. So if in each cloud we have server, data center, disk, router, processor, etc. So how we can reduce the power consumption? We need to have an efficient power management technique and algorithm is needed. Next, virtualization. In virtualization, we run several logical computers on a single physical computer using the abstraction process. So how well we can manage the resource? So what load balancing algorithm can be used effectively? Next, multi-tenancy. That is an instance, that is a VM or a virtual machine of a cloud is serving to multiple tenants of same category. So multiple users are going to utilize the same VM for specific purposes or different purposes, so that to avoid the additional investments, that is creating a new cloud instance for each and every tenant and utilizing available resources efficiently. So how to organize the multi-tenant in an efficient way. And consolidation, the process of deploying different data centers related data processing application on a single server using virtualization technology. So we'll having different configuration servers and client. Everything need to be connected, consolidated, and given it as a service model to the user. So how well we are going to consolidate and how well we are going to manage everything by considering environment as a major constraint. Next, and the very important thing is eco-friendly. So in the case of eco-friendly, environment friendly clouds is essential. We need to minimize the environment spoiling activities and ensure the non-disturbance to ecology friendliness. So these are the major characteristics which has been defined for green cloud computing. But we have challenges. How we are going to address all these characteristics? See here, the challenges that is available on Greek cloud computing in case of energy efficiency. So we need to have an energy optimization algorithm or a mechanism to attain the energy efficiency. So what algorithm can be preferred? How we are going to maintain this characteristic for environmental safety? Next, automated optimal VM. So we can't place some set of employees to monitor all the activities and do create a VM and share the VM or allocate jobs. We can't do it manually. So we need to have an efficient algorithm to perform the automation optimal VM creation with substantial resources and dynamic resource allocation and sharing facilities without affecting the cloud performance. That is the major thing. We need to always have the criteria of cloud computing here. And multi-tenancy. We need to design a secured multi-tenant architecture. If I'm going to share a VM to 10 users, all the 10 users need to access their own data, not others' data. So how we are going to maintain the privacy preserving environment in case of multi-tenant? So that is a big research in case of multi-tenancy. And in case of consolidation, we need to have an intelligent support in VM consolidation, because each and every VM is going to be run above different configuration of servers. So we need to consolidate all the resources. We need to manage the resources. We need to manage the downtime, and various threshold value calculations need to be considered in case of consolidation. And last one is eco-friendliness. The major thing, we need to have a standard for eco-friendliness, and standard need to be implemented on the cloud computing. That is going to be a comprehensive framework to certify the cloud with ranking. But how we are going to bring this green cloud computing for the real world without compromising the actual characteristics of cloud computing? So that is the biggest challenge. So out of this green cloud computing, so the need of the hour of this COVID-19 crisis is cloud-based virtual labs for online education. Since I belong to CSIT domain, we can do all the experiments from home. So we can learn from home, we can work from home, we can do all the experiments from home. So developing virtual labs as a cloud-based is a very needed need of the hour for today world, so that we can conduct all the experiments from everyone home, and the student can utilize the environment in an effective manner. So thank you all for listening to the presentation, and hope everyone have gone through the concept of green cloud computing and the concept of cloud computing. We are enjoying the benefit of cloud computing, but we need to also move on to green cloud computing as a taking care of the environment as a major constraint. Thank you one and all for this opportunity.